Welcome, everyone. Today is Wednesday, the 2nd of October, 2024, and this is the Cluster API office hours. Cluster API is a subproject of Kubernetes SIGs, and as such, we follow their meeting guidelines, which basically boil down to please treat everyone as you would expect to be treated, or explicitly so. Please be kind to each other. And if you'd like to talk, please raise your hand and I will call on you. So at the beginning of our meetings, we like to make some space for new attendees or new community members to say hey and introduce themselves. So I will be quiet for a few seconds here. And if you would like to say hi, please raise your hand or unmute yourself. All right, I'm not seeing any hands going up or people unmuting themselves. So we will move on past the introductions to the open proposal readouts. I guess we just have the in-place proposal. I don't know, is Guillermo here to give an update on that? Or would someone else like to give an update on it? Is there an update to be had? I'm not seeing Guillermo in chat, so unless someone else has an update to give on this, I think we can move on. Okay. All right. Well, let's get into our discussion topics then. It looks like the first discussion topic is from Stefan. It's a proposal for the configurable drain behavior. So please, Stefan, take it away.
Thank you. Christian, can you open the proposal and then ideally go to the markdown rendered version of the proposal. I was just wondering why there are that many changes in there. Why did I change the release team markdown? Yeah, I have to check. Probably I fixed the table of contents or something. Okay.
I can't answer that question for you. So.
Yeah, when I opened it a few days ago, but I already forgot. Okay, so back to the actual topic. So, okay, what is the proposal about? So basically, you want to make the drain behavior of the machine controller configurable. The current state is basically that we have a set of hard-coded rules how we are training machines, and that basically comes down to we are skipping certain pods, for example, static pods and daemon set pods. I think those should be the only ones. And then we just continuously try to drain everything else without any specific order until the pods are, the node is basically empty. And we have like one global timeout until which it has the drain has finished, and otherwise we're just moving forward. And if the timeout is not set, we just keep on trying until either it works or we just continue. Okay, but about this proposal. So what we want to do is basically want to make, so the biggest part of it is basically make the logic with which we decide which pods to drain and which pods not to drain. We want to make this configurable. And on top of that, we want to make it possible to define an order between pods. So basically I can say, oh, this bunch of pods should be drained before the other ones. That means basically we are training first group of pods first, then we're waiting until all of them are gone, and only then we would move to the next group of pods. So I think I go roughly quickly over the use stories, and then I just talk a bit about like how are we like planning to do this. So as I was already mentioning, we want to be able to define the drain order in which the pods are drained. Then we want to be able to exclude certain pods from drain. So there are use cases where basically people are saying, hey, I don't want to drain this pod. We identified like two sub-use cases. One is basically there are people who are just tolerating all drains. So we can evict those pods like all day long, but they will always come back. And eventually we just get stuck in a node drain. So we want to basically allow people to configure that certain pods are just excluded from drain, so we're not getting stuck during machine deletion. And the other use case is something like I have a pod that should just not be drained. It should just stay on the machine until the machine goes offline, literally until it goes offline, not just right before. Usually for that case, people, or let's say an example for that case is something like monitoring agents. So if I'm deploying some Prometheus export or some log shipping stuff, that's usually where this is necessary. Usually there's not a problem with drain because they are just deployed with daemon sets, and daemon sets are never drained. But I think it's definitely possible that people are deploying this sort of stuff or similar workloads, and they also don't want to drain, but they maybe also don't want to deploy them with daemon sets for some reason. So currently, this skips. Currently, the possibility to skip drain is basically tightly coupled to deploying something as a daemon set, which is pretty annoying. Okay, then let's see, story 4. So basically, we also see that scenario where whoever wants to control the drain behavior doesn't necessarily have access to the management cluster. So it could be that someone runs like a central platform or something, or yeah. And basically, the people who have access to the workload clusters, they have an opinion on how their pods should be drained, in which order, which should be excluded, etc., and all of that. But I cannot simply go on the management cluster and change some configuration. So basically, story 4 is story 1, 2, 3. But for the case where someone doesn't have any access on the management cluster, they can only touch their workload cluster and the pods running in them is the scenario. And then story 5 is basically that you want to be able to have a configuration and then apply that to a lot of clusters or machines. So the idea is like, I have a certain configuration in mind and I want to apply them to a set to all machines in a certain cluster, or to all control plane machines, or all Windows machines, or whatever the criteria might be, without having to duplicate that configuration everywhere. And also without having to roll out all machines and touch all machines. So basically what we're seeing here is we think that the drain behavior is not really part of the machine spec in a sense, because the machine spec should describe like the machine. It shouldn't necessarily describe how we are going to drain the machine. So that's why I think it would be good to have this configuration independent, so that people can just reconfigure the drain behavior without having to touch every single machine and entire management cluster to actually change the behavior that is used then. Okay, so much about stories. And then I would just, you can just scroll down to the first CRD example. I would just show the examples a bit. And then I would say we can answer a few questions and then just take a look after a meeting or something and review the proposal if you're interested. Okay, so how would we do this? So basically we are saying, hey, there's a new CRD, machine drain rule, which can be used to configure the drain behavior for machine drains. So we have 2 main points. The first point is spec drain, and that one basically describes how the behavior should be. So the behavior can be either drain or skip. So drain is just the default essentially, and skip means, okay, whatever matches this machine drain rule would be not drained. And then we have an order field, which allows you to define some sort of ordering. So if I have various machine drain rules, basically the pods the pods that end up with the rule with the highest order will be drained last. If you have pods that that are not selected by a specific machine drain rule, they will just end up with order 0. So basically 0 is the default, and then you can just decide should it be early or later, and then you can figure out some rules and some grouping. Totally flexible with that. Okay, and the rest of the CRD is the selection to which this rule to which objects this rule applies. So on one side, we want to be able to select a certain machines. So we have a machine selector if you want to select directly on machine labels, but also a cluster selector in case you want to select based on clusters. The idea is that the machine selector and cluster selector, they are ANDed. And if you have multiple array elements in the machine's array, these are ORed. So you can basically just do whatever you want here to deselect on a lot of stuff without having to duplicate the drain rules very often. And the same applies to pods. So pods is then, of course, in the workload cluster. And here you can select directly on the pod labels, or you can select on namespaces in which the pods are. So what you essentially do is you will deploy a set of machine drain rules. And when we go into an actual machine drain, we will get a list of all the pods that are on the node. Then we will basically decide, okay, which pods should be drained, which ones should be skipped, and the ones that should be drained, in which order should it be drained. What we're not going to touch, the current behavior is that daemon set pods and static pods are never drained. And we want to keep that the same, at least for now. The reason is, if you would drain or evict the daemon set pod, it will just immediately come back, because the daemon set controller will put a toleration for the unscheduled taint on every single daemon set pod. And the unscheduled taint is basically the one that is used when a node is cordoned. So we could try to evict the daemon set pod, but it will be always rescheduled immediately. So if our goal is to have a set of rules, what pods should be exactly drained, and we would include daemon set pods there, there's no way to reach the goal that all of them are going away. So we're saying, okay, daemon set pods, let's just continue to skip them. And the situation for static pods is similar. So you could evict a static pod, but what happens is that a pod object vanishes. The actual pod doesn't vanish, it just keeps on running, and the kubelet will recreate a pod object. So there's like literally no way to get anything done that. So static pods, daemon set pods, we just continue to ignore them. But for everything else, basically those drain rules apply. Yeah, we basically take the pods. We take the machine drain rules that are matching to the machines on which the pod is running. And then we just see, okay, which rules are matched to which pods. And then we are picking the behavior and the order from the matching rules. Yeah, so that's the main thing here. Let's scroll a little bit down. So that's like the main use case. Someone has access to the management cluster. People can deploy those CRDs into the management cluster. But we also had the other use case, which was around what if I don't have access to the management cluster? You can scroll down until the annotations. Yeah, and what we're proposing is basically for that use case to introduce two annotations that can be put on single pods. One is drain, which is basically drain behavior. So either you are going to drain or you're going to skip. And if you're going to drain, then you can also have a drain order. So it gives us the same information if those are on a specific pod. And the annotations will override what is configured on the management cluster. Basically, it's because the more specific configuration, right? I mean, if I have a drain rule on the management cluster, which just defines behavior for a bunch of pods, and then I have a very specific annotation on one single pod, which says what exactly should happen to that pod, then that should have the higher priority and be used. Yeah, I think that's the TLDR. The rest of the document is a bit like, okay, how exactly would that matching logic work? In a few details, but I think that should capture most of it.
Thank you, Stefan. This is really interesting stuff. I guess I have a question, but I'll also open it up here. Does anybody have questions or comments they'd like to ask about this proposal? I'm gonna selfishly start with my question then while people are getting geared up. So like this seems really useful to me, and the notion of like almost like pod drain dependencies and whatnot seems like a bigger issue than just something a cluster API would have to deal with. And I'm just curious, like, was there ever any like, did we ever reach out to like, I don't know, like SIG app or anything like that to see if there were others kind of like exploring these type of things? Fabrizio, I see you got your hand up. Did you want to respond or did you have another question?
I can respond and also yeah, add a few comments on top. So, but let's start from the first comment is this PR. I really like this effort. There is a huge research effort behind, and it is solving actual problems. So today we got user with yeah, drain stack, or they are not able to drain workload in a meaningful order. So I think this is super important. With regard to what is happening in Kubernetes about and yeah, just going a step back. So there are a couple of issues in our backlog that describe which are the use cases that this proposal address, and some of them are very old. So this is a very welcome change, and that sum up with all the other work that for improving observability on drain, so and performance on drain. So this is definitely one of the highlight of this CAPI release. Going back to what is happening in KK. So currently in KK, there are two proposals which are driven by SIG app in this area. One is the node maintenance proposal, and the other is the evacuation API proposal. Yeah. Is that correct? The right
Yes.
name is yes. Sorry, it is. So the evacuation API is a sort of layer on top of eviction. Probably it is, and eviction is already on layer on top of PDB and deletion. So it's kind
Well,
of getting
I would
really
say evocation
complex.
is sort of like cooperative eviction or something.
Yeah, exactly. And it requires basically controller to, yeah. It is probably designed to, I don't know, operators that they manage some pods. I don't know, etcd operator where you need a strict order on what happened, and in my opinion, it addressed this use case, or at least this is my understanding.
Yeah,
Okay.
just one quick note. So there's basically also like a long list in the proposal, in both rules actually, but there's a long list of limitations of PDBs today. If people are curious about that one, please look at the caps, and they're trying to fix most of them, I think.
Yeah, exactly. So it is something really advanced, and I don't think that it overlaps with this proposal. Instead, the node maintenance is slightly different. So there are part of the node maintenance proposal that do not overlap with this work. So they in the node maintenance, basically they want to give a declarative API to declare, oh, this node is going in maintenance. Which is something that in cluster API we don't need now, because the only maintenance operation that we do is when we delete the API. So it is already somehow declared, I want to delete a machine. So we don't need another API to declare the same thing. Okay. There is a sort of overlap with regards to the fact that in the node maintenance, they are also defining a sort of drain rules. However, they are different. And also the scope of this proposal of node maintenance proposal is different. So what they are trying to do is they are trying to figure it out, very complex things like, oh, we want to drain static pods, or we want to drain daemon sets, which is something that Stefan work is not. Stefan work is just building on top of what Kubernetes offers. Instead, they are trying to change the rule in Kubernetes. And so even if they are defining node drain rules, they are different, because their rules are not designed from a, let me say, from an application point of view. Their rule targets type of pods. So you want to say they allows you to define a rule for static pods, which is not what we want. We want to be near to the users. So there are some overlap, but not so different. And I also have to say that there are a lot of discussion, some of them triggered by me, and some by many other contributors. So it's not really clear to me if node maintenance proposal is going to land in the current state. The author is saying, yeah, there is a lot that we have to find consensus. There is also someone suggesting for that proposal to not be implemented in core Kubernetes, but be implemented as a CRD somewhere. So it has some incubation time. So TLDR is, there is work in SIG. Some of them I don't see it overlapping. Some of them is partially overlapping, but not fully. They are trying to solve slightly different problems. And the last point is, even if, okay, if we look at this, first of all, we don't know when this will land. And in cluster API, we are also to support very old Kubernetes version. So, okay, it's not easy to figure it out when we can use it. And the second angle is even if something lands in cluster API, there will always be a gap because cluster API is by definition multi-cluster. Instead, whatever they implement in Kubernetes is for one single cluster. So we always have to think about how to solve our problem in the management cluster, how to apply rules to many. So long explanation because the problem is complex, but I think that what we are doing is good. We can eventually down the line trying to benefit of new feature that pop up in Kubernetes when they pop up. But I think that this solve a problem that that our customer have, and it will help also to to bridge the two worlds in future. I don't know if Stefan and my long explanation makes sense.
No, makes sense.
Yeah, no, thanks, Fabrizio. Like that was more or less what I was interested in, like just to kind of hear about the due diligence. And it sounds like, and I totally get like what we're going for here. And it sounds like, yeah, like there's just not enough overlap to make it, like kind of a core thing at this point. But yeah, like that really helped me out. I appreciate it.
Yeah, maybe just one quick comment.
Yeah.
I think this basically will be some sort of parallel exercise between us already building something on our side that we can use, and then on the other side trying to contribute to what happens in Kubernetes, and then in a perfect world eventually align and build on top of that, because it could also end up that they build like a building block that we can then use and build on top. But it's hard to say at this point. And yeah, it will definitely take us literally years until we can fully rely on it, because I mean, we're supporting N-5 versions, which is already 2 years. Then a cap has to be merged, implementations have to be merged. The stuff has to become at least enabled for default, maybe even GA. It currently sounds like this proposal has to at least touch, I mean, they have to implement the new node maintenance API, the new evacuation API. They're both non-trivial and require new controllers in Kubernetes. And they also have to touch the daemon set controller, kubelet. So it's like a really big one. So I would imagine that in very best case, we're talking about 3, 4, 5 years or something until it's supported in all versions that we want to support.
That's a great
just
point.
A very wild guess from my side.
No, but that's a great point. I mean, it is kind of like the lag effect of things getting into the core. And I really appreciate the work that's been done here too. Like it looks like a really good feature for what we need to use it for. Okay, Sandhya, you've got your hand up, please.
Yeah, I haven't had a chance to read the proposal yet, but definitely seems like it's a super useful behavior that you're trying to add. But I wanted to ask specifically about the cases where when a specific pod is okay to be drained, but then we encounter failures. So do you want to separate that category into proceed even if failed, or stop the drain if we have failed? If you want to define the failure situation a little bit more.
Currently, we were not planning to change anything there. And the current state is essentially that once we identified that a pod should be drained, we are just continue to try to evict it. And then we are going to wait until it's entirely gone. That means like deletion timestamp is on there and literally the pod object doesn't exist anymore. That's the current state, and the proposal doesn't change it. What we changed recently is just that we are surfacing the situation a lot better than before. So that's just on main, not on the last release, basically that we write the conditions where you can exactly see, hey, this machine is not is still draining because we have we encountered those errors, and some errors are like, oh, this pod is still there, but it already has deletion timestamp, or we couldn't evict this pod because the eviction API blocked us because of this PDB and something like that. So yeah, that's the current state, and no changes planned at the moment, at least.
Cool, thanks.
Maybe one quick note. The reason why we are currently doing it that way and weren't thinking about changing it is essentially that we think that, so the number one reason why a pod does not get drained is because a PDB is blocking it. And a PDB usually means that someone on the application side made a decision. I really need this pod or a certain amount of those pods. So we were in general thinking that we should definitely respect those PDBs under all circumstances, because otherwise, basically, people on the management cluster risking uptime of workloads in the workload cluster. So that's why we didn't really think in that direction.
Yeah, thanks for the why behind it. That's really useful.
Cool. Does anyone else have questions or comments about this? And Christian is saying in chat that PDBs may block the drain because something different is broken as well.
Yeah, I heard of cases that basically, I don't know, someone rotated a registry certificate and no pods are coming up anymore. And then also stuff like PDBs are very useful, right? And if you don't have that, if you're on one side, if you don't have the PDBs, and on the other side, if you don't have something that respects the PDBs, it can easily happen that an upgrade goes through entire cluster and not a single pod is running afterwards. So yeah, people should be careful.
Well, that's like the Ouroboros of PDBs or something like that. I don't even know what to say about that. Okay, so if nobody else has questions or comments about this, please go check out the proposal and leave any discussion there. All right, moving on to the next topic. Fabrizio, you've got a PR for API changes. Please take it away.
Yeah. Most of you know we recently merged about a PR for improving status in cluster API resources. This work that is targeting the V1 Beta 2 API. We are adding types, but they are below a struct, and this allows us to experiment, implement, and then get ready for the big switch sometime in the next version. So I have this huge PR, which is basically adding all the new struct to the API. Thank you everyone for the comments so far. A lot of great feedback about Go comments, validation, etc., etc. But what is important is that so far no substantial changes from what has been discussed in the proposal. So yeah, I hope that we can get this. So the PSA is first of all for giving a shout out to folks which are helping and provided feedback. And second, just a PSA that if things goes continue this way, probably we can get back this merged by end of week, I hope, and starting next week with the rest of the implementation of the proposal.
Yeah, I noticed there were a lot of comments in the last couple days on that PR as well. So I mean, if you think we're close to getting it merged by end of week, I think that's really cool. I'm
Yeah.
wondering, should we put any sort of like consensus period in the PR or?
I don't think so. Let me say, as I said, so there was a lot of comment, but the good thing is that most of them were needs, Golang comments, make Kubectl explain better, some clarification. But as I said, there was no big change. There was no any change with regards to the proposal. So yeah, a lot of back and forth and a lot of patience from the reviewer. But yeah, I don't think we need a lazy consensus. It is just a huge PR that touch the APIs, so require attention, and every detail is important, more important than usual, let me say. And yep, it's getting through the doors.
Okay, cool. That's good to hear. Stefan, please, you got your hand up.
Yeah, I just wanted to agree on that. So basically we had the proposal open for a while and we're going back and forth, and basically only details really, I wouldn't even say changed. It's more like if you copy a type from the proposal into actual Go code, you might want to change the comment a bit, and then there are copy paste errors and new Go comments that you didn't have before. And I mean, that was like 90% of my comments on that PR. So I think we're at a point where we're pretty close to just being able to merge it. The important thing for us is just that we have an umbrella issue of, I would say, like 40, 50 subtasks that have to follow on top of that PR. And basically what we like to do is just relatively soon like de-risk the entire effort by getting this PR already in. That's why it would be good that if you're able to merge it in like 1 or 2 days. I think we are probably already today in that state, but worst case until the end of the week that we say, hey, like this PR is like to 99% fine. And if someone finds after merge, like this Go doc comment should look slightly different. I mean, we can do a follow-up PR. That doesn't really change anything, but it helps us that we can already build on top.
Cool. Thank you. And appreciate the extra context there. Does anyone have questions about this or comments? So hopefully, yeah.
Mike, sorry, can I?
Oh, sorry. Go ahead, Joel.
Sorry, I didn't raise my hand. I can't find the button in Zoom. So I went for a review earlier and left a bunch of comments. Thank you, Fabrizio, for fixing those all up. I will go through and just check on some of those again. One of the ones that I left was about the length on the conditions list. I did just leave a comment on there, which I see Stefan has already seen. You asked whether it was something that is an API convention already. It is not, but I think it's going to become that way. So in general, adding length limits is always a good thing. You prevent people putting garbage into your API and kind of overflowing. But the more important thing here is cell and the way that cell does runtime cost analysis. So in the future, if we ever wanted to add any cell validation that looked at the conditions list, for example, it would try and calculate what the cardinality of the rules are. And by doing that, it has to work out the maximum length. If the maximum length isn't defined, then it does a calculation based on what it thinks the minimum serialized size of the object would be, and then divides that into the size of XED storage per object, which is like 3 megabytes. So you can easily get to like millions of executions if you haven't set a size limit. So what I've been doing, and I've spoken to other API reviewers, both within Red Hat and outside of Red Hat, basically we're kind of building consensus that every list should have a maximum limit. And if you can't easily define one, just go big, but not too big. So that's why I suggested for the conditions, right? Let's go for maybe 32. We think in any case, there should only be 6, 7, 8 anyway. So 32 gives us plenty of headroom, but it means if we ever did want to add any cell validations, we're not going to hit this cardinality calculation. And in theory, we shouldn't blow the runtime cost budgets. So yeah, I thought I'd bring that one up just because it might warrant some further discussion if people have questions.
Yeah, definitely good thinking, Joel. Stefan, please.
Yeah, just have one small addition for people who might not be too familiar with cell and the COD validation. So the runtime cost calculation, why that is important is because the API server has hard limits on what it accepts. So basically, let's say we are publishing this API type like it is right now without the max length. And then if you ever want to add a cell validation on some of that stuff, on the update request where you want to try the cell request, the API server will estimate how long it will take to run this thing. That's what Joel already mentioned. But if you're above a certain threshold, then the API server will just not allow you to add that cell validation because it's just saying, hey, if someone ever deploys a CRs, it's just too expensive for me to run this thing. And then you're in that situation where you either have to decide, I'm not going to add a cell validation because I forgot to add a max length half a year ago, or you have to add a max length at this point, which could be considered a breaking change, right? If you don't put a limit on it now, then people with 33 conditions will complain. No, but I mean, it's always easier to go up with max length than trying to go down, and then you have to worry about people breaking. So the reason why I'm sort of aware of the problem is I was trying to write unit tests for the cell validation that we implement for clusterless variables. And basically, it took me quite a while to go up and down entire schema to add enough of those max things everywhere to actually get the cell stuff even deployed so that it can be executed afterwards. It's really a bit annoying and tricky. So yeah, definitely agree. I didn't see that when we were discussing it before, that cell angle.
Yeah, thank you, Joel, for the contest. I will. Is that okay for everyone? 32 max number of conditions. Okay, consider it done.
That was easy. Thank you very much.
And I'll give a quick shout out here if anyone is curious about cell validations and budgets and whatnot. Joel is giving a talk at KubeCon about it, so mark that on your calendar.
If I can find the time to write it between now and KubeCon.
Let's keep that off the record, okay?
I mean, people always find time eventually, right? Even if it's just the night before.
Right, you got a long flight to come over here, Joel. All right, are there any other questions or comments about this PR? All right, I'm not seeing any hands going up. So that brings us to the end of our regular discussion topics. I will get into provider updates. It looks like Richard has something about Kappa. So please, Richard.
Yeah, sure. So this is just really for anyone that's using Kappa and the publicly available AMIs. So we've had an issue for quite a while now, but we haven't been publishing new AMIs for new Kubernetes versions. That's been a known issue for a while. And that's mainly because we've lost access to the accounts, straight the people at VMware that were publishing them for us. They were published to a VMware or VMware account. So that's been a known issue for a while. What we're seeing more recently, though, is the existing images. So these ones that have existed for quite a while are now being deleted automatically by AWS due to deprecation policies on the AMIs. So literally in some regions, publicly available AMIs are all gone, and the other ones are slowly disappearing. So if you are using publicly available AMIs, and this only applies to non-EKS clusters, then the advice is to build your own images, use an image builder for the time being, and put those AMIs into your own account until we resolve this issue. And the resolution is there is a CNCF AWS account that we can use for AMIs. It's just getting the automation and everything in place, and the access is proving quite long-winded. And it wasn't so much of an issue when we did have some AMIs, but now it's in time critical. So we will accelerate that as well. But yeah, feel free, if this impacts you, just to reach out in the AWS provider channel and we can help you.
I feel like this is a really important update at the end of the meeting here. Fabrizio, you got your hand up, please.
Yeah, just to first of all, thank you, Richard, for taking care of fixing this. I just want to call out that maybe in the past we were a little bit, yeah, we were just too worried to make things to work, but we really have to put care of using community-owned stuff. And yeah, we also recently discovered a similar problem for CSI images of InfoSphere. So it is not only machine images, but it's also Docker images that we have to take care of moving. And most of it has been fixed this summer before the migration of test infra to community-owned account, but no, there are still some left over. So the TLDR for everyone, please check where your images are hosted, if it is, and both Docker images and machine images. If they are not hosted on community-owned infra, get this fixed soon.
Yeah, well said. And I think, like I was going to say before, I think like if you're watching this on the recording or something and you're a cluster API AWS user and you notice that your machines like stop getting created because the AMIs are being rejected, please reach out in the cluster API channel or the cluster API AWS channel. And I see Nolan is also putting a comment in chat here that this is going to come up for discussion in the Kappa community meeting. But for now, the safest is for users to build their own AMIs until we have some CI in place to kind of do all this. And Richard, you've got your hand up as well, please.
Yeah. Just to follow on that, there is some regions with the images still available. Nolan found in US East 1. So there is a feature of cluster AWS ADM, so the CLI utility, and you can copy AMIs to a different account. So if you don't want to build your own, there's still some time while we still have some images to use that to copy them into your own account if you want to, which I'm going to be doing straight after this call, incidentally.
Good deal. And I think Fabrizio's got a great comment in chat here too. It's just, kind of a good reminder that, community owned or community supported images are probably not the best thing to use in production. That, you should have some way of reproducing the images that you're using in your production. And, thanks to all the Kappa maintainers for bringing this up. This is a good point. Are there any other questions or comments about this one? Okay, not seeing any hands going up. So thank you again, Richard. And I'll move on to the feature group updates. We're going to have a Carpenter feature group meeting in about 15 minutes. We've put up a small PR to adjust the charter of the group, but nothing major. All things we've discussed here about kind of getting into the enhancement and experimentation work. So hope to see some of you there. And that brings us to the end of our agenda. Does anyone have ad hoc topics or last minute things they want to bring up for the group before we get about 15 minutes of our day back here? Going once, going twice. Okay. Let's call it a meeting then. Thanks everyone for coming out, and we'll see you next week.
Thank you.